Hi, today we want to learn urban vegetation detection using Sentinel-2 image in a Google Earth engine. Urban vegetation detection plays a vital role in urban planning, environmental monitoring, and assessing the impact of urbanization on the surrounding ecosystems. Urban vegetation contributes to various environmental benefits, such as improving air quality, providing recreational spaces, mitigating urban heat island, and enhancing the biodiversity. In this tutorial, we will demonstrate how to Sentinel-2 Surface Reflectance or SR data to detect the vegetation in urban areas. We will employ Normalized Difference Vegetation Index or NDVI to differentiate between the vegetation and non-vegetation surface and apply custom color transformation logic to highlight the urban vegetation in an innovative way. Application of this in a urban planning, identifying the green spaces with a urban environment can help city planner prioritize area of green infrastructure development in environmental monitoring, tracking urban vegetation health over time, and helps assess the effectiveness of a urban greening initiative and in a biodiversity conservation. Urban vegetation detection aids in understanding the biodiversity pattern and ecosystem service in the cities. In a coding part, we first define the area of interest. We define the Paris cities areas and maps into object of Paris. And after this, the zoom, we select the zoom level 12. And after this step, next load the Sentinel-2 Surface Reflectance data from Earth Engine catalog and filter the data for the specific data range, June 2023 until the after the 3 months after this. And for an area that include Paris, we also apply the cloud coverage filter to ensure we are working with the high quality image. And after this, we can select the different band. We added the median for reduce the cloud effect and divide it to 10,000 to scale the reflectance to 0 to 1. And we select the band 2 is a blue color, band 3 green, and band 4 is red, and near infrared band 8. And after this, we calculate this and compute the NDVI values with this formula. And NDVI equal the near infrared subtract red divided near infrared plus red, and NDVI helps to differentiate between the vegetation and non-vegetation surface, and higher value of NDVI correspond to the healthier and denser vegetation. And step 5, we use it RGB and grayscale calculation. We then compute the grayscale and RGB values for image, and this operation is used to create a custom grayscale color transformation based on a red, green, and blue band, which will aid in a visualization vegetation highlights. And because we use the B0 multiple B04 multiplied 2.5 and other band similar, and we define the variable of a multiply 0.2 and add g dot multiply 0.7 and add multiply b multiply 0.1 and we name it y, and we use it the vegetation threshold and masking. To detect the vegetation area, we apply the threshold to NDVI areas, and the NDVI values greater than 0.4 are considered vegetation, and this threshold helps distinguish between the vegetated and non-vegetated areas, and we create a binary mask when vegetation areas are marked as a true and non-vegetation area as a false. And step 7 is a color transformation logic. Using the vegetation mask, we apply custom color transformation logic to highlight the vegetation, and areas identified as a vegetation will have their own unique color transformation, shade of a yellow, and the non-vegetated area will have a uniform color. And in step 8, the combining a bond to from the custom RGB images. We combine the individual color bonds red, green, blue into the final custom RGB image that highlight the vegetation areas with the desired color transformation. And step 9 and the final step will be visualize the results on the map, and the two color composite and custom RGB image are displayed with the vegetation areas highlighted in the custom colors. If we run this code, you can see for the Paris areas, we have a green color vegetation areas and gray color for urban areas. This is for 2023, and you can change this to 2024 and run again. Yet we have not a non-cloud image. We can test in a 2022, and as you can see, we have a urban vegetation areas, and you can generate the geotiff of this. If you don't know how you can generate the geotiff, you can watch the video of a berry source detection with the Sentinel-2, and if you want to analyze the time series, you can watch the video of a soil moisture of a Sentinel-2. Thank you for your watching. Please like and subscribe our channels.